Hello and welcome everyone. Finally, after so many days, we have an interesting problem. Question name is shortest path in a weighted undirected graph. So we have a graph and we have to build a graph. We have given edges and it's a weighted graph and we have to tell the shortest path. So the answer must include the weight and the path starting from the starting node. Starting node is 1 and we have to reach nth node, and remember it is 1 based indexing. So let's build this graph. So we have this graph and we have to reach starting from one node to nth node. So our target is starting node is this and our target node is V. V means vertices. Here we have 5 vertices. So its prerequisite is Dijkstra algorithm. Okay, so if you don't know, let me explain you to first what is Dijkstra algorithm. So Dijkstra algorithm help us to find the shortest path starting from the given node to every node. So it will return an array. So 0, 1, 2, 3, 4 and 5. It will return you an array. So initial, so let's go step by step. Our first step is to do the Dijkstra algorithm. So initial value is maximum value, every value is maximum, and we have to start from 1. We have to start from starting node we have given as 1. So if I am here and I have to reach this node, so the minimum weight or the minimum weight, the minimum distance is 0. So it's 0. So Dijkstra algorithm uses priority queue. So let me build a priority queue. So priority queue, here we have two things. Sorry, let me build a priority queue. This is the priority queue. Let's assume, and in priority queue we have two things. First thing is vertex, and second thing is weight. And priority queue sort it with the minimum weight. So minimum weight. So we have to reach starting node. So this node is visited and vertex is 1 and distance is 0. So initially we have this node or this into our priority queue. So let's do the algorithm. Our first step is to pop an element. So we have popped an element. Our vertex is 1 and our weight is 0. So starting from 1, we can go to 4 with weight 1 and we can go to 2 with weight 2, because till here we have a weight of 0. So we can go to 4 with weight 1. So this is the weight. Let's change the weight and add into our priority queue. So we can reach 4 with weight 1 and we can reach 2 with weight 2. So we can visit second vertex with weight 2. So this is done. So again, let's pop out the minimum weight element first. So this element will pop out. Its vertex is 4 and weight is 1. So vertex is 4 and weight is 1. Starting from this vertex, we can go to this vertex. So till here we have a weight of 1 and we can go to this node with weight 2, because here we can reach with one node with one weight and one distance we have to add to reach 1, and we can go to 3 with weight 4. So as you can see, we can reach one node with 2, but here minimum is there, so we will not update 1, but we can update 3. So we can reach third node with weight 4. So let's add and add it to our priority queue. We can reach 3 with weight 4. So this is done. And let's pop out next element. Next element is 2 2. So our vertex is 2, weight 2. Vertex is 2, weight is 2. So starting from here we have this vertex and we can go to this. So we have till here weight 2, we can go here with weight 4, with weight 4, and we can go to this vertex with weight 6, and we can go to this vertex with weight 7. We can go to vertex 1 with weight 4, but minimum is there, so we will not update 1. And we can reach 3 with weight 6, but 4 is already there. We can reach 5, so with weight 7, so we will reach 5 with weight 7. So it's done. Okay, so we can reach 5 with weight 7. Yes, and our next node is this node. So 3 and 4, vertex is 3, weight is 4. Vertex is 3, weight is 4. So vertex 3 with weight 4. I can go to this node with weight 7. I can go to this node with weight 5, or I can go to this node with weight 8. So let's update our weight array. So we can go to weight first vertex 4. So vertex 4. So this is minimum. So we will not update this. We can go to weight vertex 5 with weight 5. So we will update this. We can go to weight vertex 5 with weight 5, and we can go to vertex 2 with weight 8, but we will not update this because it's already contains minimum value. So we can go to weight vertex 5 with weight 5. You can stop here because we have reached our target node with minimum value, or you can still continue, but that will not benefit. So we will remove an element. So 5 5, we can go to 5 with weight 5. So 5, from 5 we can go to this node with weight 6. From 5 we can go to this node with weight 10. So we will not update anything because it will only increment. Next node we have 5 and 7. So we'll remove vertex 5 and our weight is 7. So we can go to this node with 8 with weight 8. We can go to this node with weight 12. So we will not update anything. So that's the overall approach, and it is the Dijkstra algorithm. I hope now you got it. What is Dijkstra algorithm? So as you can see, from starting node is 1, we can go to 5 node, fifth node with weight 5. So it will give us the minimum weight. So as you can see, this is the path. So we have to return our answer. We have to first add the weight. The weight is 5, but we have to also add the path. What is the path? We have to find out the path. Okay. So one more thing, if the V vertex or the target vertex is unreachable, unreachable means it contains maximum here. It will contain maximum. So if let me check if weight of vertex containing maximum, then we have to add -1 and we have to return our answer. It is given in the description, but according to this graph, 5 node or vertex node is reachable and its weight is 5. So you are familiar with the Dijkstra algorithm now. So we have to find the path. So how to find the path? How to find the path? It is the main concern. So we will maintain two arrays. One is the weighted array and 1 is the parent array. 0, 1, 2, 3, 4, 5, and 0, 1, 2, 3, 4, 5. Let me erase this. So initially weight is maximum, default value is maximum, and we have this node as starting node. So this is the starting node. So starting node weight is 0, and its path, its parent, we can say 1. So its parent is this only, 1 only. So we can reach 1 starting from the starting node only. So its weight is 0 and path is only 1. So let's go to other nodes. We have a priority queue and we will run Dijkstra algorithm. So in the priority queue, we have 1. So this is the vertex, and the second is the weight. So this, we have this into our priority queue. First thing is vertex and the second thing is weight, and we will sort according to weight, sort according to minimum weight, because we have to find the minimum distance. That's why. So first pop out this element. Yes, we pop out this element. We can reach this node with weight 0, and we can reach this node with weight 1, and we can reach this node with weight 2. So let me update the weight array. We can reach 2 with weight 2, and we can reach 4 with weight 1. So as you can see, fourth, this node parent is 1. Fourth node is reachable by 1 with the minimum distance, and the second node, second vertex is reachable by 1. So on the neighbors we will add parent. So second parent is 1, as you can see, second parent is 1, and the note third we have fourth. Fourth parent is 1. It contains the parent. It will help us to find the path. So that's it. And we have to also add into our priority queue. Remember, node is 4, weight is 1. Node is 2, weight is 2. Next, remove the uh, minimum weighted node. So this is the node. So we have this. So we can reach this node, and we can reach this node. We can reach this node, and till 4 we have weight 1. So we can reach one node with weight 2. But this node, this weight already contains the minimum value. So we will not update our weight and the parent array. We will only update the minimums. So we can reach 3 with weight 4. We can reach 3 with weight 4, and 3's parent is 4 now. So as you can see, fourth neighbor is 3, and 3 node is reachable by 4. So it will contains the minimum path and the minimum weight also. So let me add into our priority queue also. Node vertex is 3 and weight is 4. Yes. So let me erase. Okay. Our next node is this 2 2. So we can go to this node. We can go to this node. We can go to this node. So 2 weight is 2. We can go to 4 with 4 with one vertex with 4. We can go to third vertex with 6 weight, and we can go to fifth vertex with 7 weight. So 1 is minimum, then third we can go with 6 weight, but already contains the minimum. Then we can go to 5 with weight 7. So we can go to 5 with weight 7. So now fifth neighbor, fifth parent is 2. Fifth parent is 2. So let me add 5 into our priority queue. So we can go to 5 with weight 7. We don't have to worry at the end. The path array will contains the minimum path. So let me pop out the next element, 3 with 4. So 3 with 4. So starting from 3, we can go to this node with weight 8. We can go to this node with weight 5, and we can go to this node with weight 7. We can go to fourth node with weight 7, but it contains the minimum. We can go to 5 with weight 5. So let me update this, 5, and it contains the parent. Parent is 3 now, and we can also go to 2, 2 with weight 8, but 2 contains the minimum, so we'll not update this. So that's all. And we have to add, I missed, we can go to 5 with weight 5. So next element is this 5 5. Then we can go to this node, we can go to this node, but this will not affect our the weight array and the parent array. And we can go to 5 with weight 7. Then we can go to this node, we can go to this node, so this will also not affect our minimum weight and the parent array. So that's all. We have reached our uh, target variable, target vertex. So let me erase the priority queue, this and this. So as you can see, it is reachable. So we will check is weight array of vertex. If it contains maximum, means it is unreachable, else it is reachable. So first we have to add the weight. So answer dot add, we have to first add the weight. So weight of vertex we will add. First it contains the 5. As you can see, this is the path, and its weight is 1, then 3, then 1. So it contains 5, and we have to also add the path. So we have this node, first this node, so our node value is 5. So first we will add 5, then its parent is 3, then our node is changed, we have this, so 3. Then we add this, then its parent is 4, so then we go to 4. So then we go to 4, so add 4, then its parent is 1, then we go to 1, 1, so 1, so 1, we also have to add 1, so we'll add this. First 5, then 3, then 1, then 8. So that's the answer. And output, I think the path is not written here. We have to return the list. This list contains the weight and the path. So uh, it is given here in the description. So the path is 1435. So we will add this way. So 1 5 3 4 1 or 1435. That's the path we will add. So we have given edges list, edges array. We have to first build our urgency list. So I will build the urgency list. So urgency list, it contains, so I will made it like this. So it is one based indexing. So as you can see, one is from 1 we can go to 2 with weight 2, and we can also go to 4 with 1. So then from 2, from 3, from 4. So this is a list, and inside this we have a list, and inside this we have data. So data contains two things, one is neighbor and one is weight. So we can add it in different ways. So I will first make a class. We have a neighbor and we have weight, data, urgency list, new urgency list. So I have to add the vertices. it is one based indexing. So be careful while making your graph and your visited and parent array. It must be v plus 1 or n plus 1. So then add the edges. Adjacency dot get of e of 0. So it is a, then I have to go to b with weight. So I can go to v, this is the vertex with weight, so this is the weight. And remember, this is the undirected graph, so we can also go from b to a. B to a, I missed the constructor. So neighbor and weight, you can use this keyword, this dot weight is equal to weight. So that's it. And then we will run Dijkstra algorithm. J-E-S-T-R-A, I think it is this, if I am not wrong. Dijkstra, yes, the spelling is correct. So we will pass n, m, we don't need m, so then we will pass adjacency list. Yes, that's it. And it will give us our answer or our list. So we have to return list Dijkstra and then your adjacency list. Adjacency list. Then we have to make this weighted array. So weighted array n plus 1 and parent array n plus 1. N is so n is the number of vertices. So first we have to fill our weight. Arrays dot fill weight with the maximum value, because we have to find the minimum. So starting node is 1, so its weight is 0. So parent also 1, parent is 1. Then we need a priority queue, and in this we have two things. First thing is vertex, and the second thing is weight. Priority queue, new priority queue, and we have to sort it according to minimum weight. So dot 1 minus o2 dot 1, that's it. And we have to, so first add new int. So first thing is vertex and its weight, yes. And our next thing we have to return, so we will do this afterwards. If priority queue is not null, is not empty, if priority queue is not empty, then pop out priority queue dot remove. So our current node is pop of 0, and our current weight is pop of 1. So we have this, and we can reach to other vertices. So we have urgency list for that, and we have data. So neighbor nodes, I have used for each loop. You can also use for loop. So urgency dot get of current node, so it will give me neighbor nodes. So I have neighbor nodes. So first neighbor node is this, neighbor nodes dot neighbor, and neighbor weight is this, neighbor nodes dot weight. So neighbor nodes dot weight, if so we have this. So first build a graph, so we can reach with this, and we can go to this. So in priority queue we have vertex 1 with weight 0. We can go to 2. So we have to add this weight. So vertex is this. I know vertex is this. And we have to add current weight. So current weight plus neighbor weight. So it must be less than the already filled of neighbor node weight, neighbor node. If it is less, then only we have to fill our neighbor node weight with the minimum. And remember, we have to also initialize our parent. So parent of neighbor node. So current node is the parent of the neighbor node. So that's it. That is the priority queue. Let me check if there is any mistake. Answer, we have to return answer list. Initially left, let's return it with -1 only. And first check the weight. So let me run this. No, there is a mistake. So I found out the mistake. So the mistake is I'm not adding into our priority queue. We have to add into our priority queue. So new int the neighbor node and it's a weight. So neighbor node weight. So weight of neighbor node. So that's it. Let's run one more time. Yes, we have a correct answer. So we have found this. Now we have to find out the path. So let me do one thing. If weight of the vertex, weight of n is unreachable, it contains maximum value and it is not reachable from any node. So we have to add -1 and return. Else we have to add weight. First weight, then path. So add our weight to reach n. Yes. Then we have to find out the path from the ending node. So ending node is n. We have to find its parent. While node of while parent of node is not equal to node. Till we have this, we have to add into our answer list. Then node will be parent of node. So it will go to parent. So remember, we have filled parent of 1 is equal to 1. So we have to also add 1 here. So you can add node or you can add 1. Anything. So let me erase this and run one more time. Now it is working fine. Let me submit it and see if there is any error. Yes, we have successfully submitted this code. If you are watching till now, a click on the subscribe button is appreciated. And thank you all for watching this video.